Hello everyone. Today we'll start with your next numerical using moment distribution method over there. Okay. So this will be the next numerical, that is you have to analyze the given beam using moment distribution method. That is a continuous beam ABCD is provided to you, out of which joint A and joint D are fixed on over here, while joint B and C those are having a simple support over there. Okay. About the loading, between span AB, a point load is given at the center 2 meter apart from A and B, and a UDL is acting from point B to point D at a distance 6 meter and 4 meter in two spans over there, that is BC and CD, of 15 kilonewton per meter. And along with that, at support C or at point C, a concentrated moment of 10 kilonewton meter is acting in this beam over there. Okay. So concept is what over here, how we have to use this 10 kilonewton meter moment while solving the numerical over there in moment distribution table over there. Right. So we'll proceed with your numerical over there. So we'll start with the solution first. In solution, your first step is that you have to calculate the value of dk. So dk at joint A and D, those are fixed ones, so dk will become 0. That is your basic known values, theta A and theta D will remain 0, while your unknowns value will remain at theta B and theta C. So total dk value will get equal to 2. Those are your theta B, I am assuming those clockwise rotation initially, and theta C. So these will be your basic unknowns over there. Okay. And theta A and theta D due to the fixed support, so this will be your basic known values. Right. After that, we'll proceed to your next step, step number 2, that is we'll calculate the fixed end moments over there. For calculating fixed end moments, what we do, we consider initially all the joints as fixed one. So we'll start with your first member, MFAB. In MFAB, what is given to you? In AB span, a point load is given at the center. So fixed end moment comes equal to minus WL by 8 minus, since restoring sign is negative over here, that is restoring moment will be anti-clockwise. So that is why we consider here negative. So if you calculate this, W is given to you 25, length of span AB is 4 divided by 8, you will get this as minus 12.5 kilonewton meter. You check this value, you will get as minus 12.5 kilonewton meter. Same way, MFBA, restoring moment will be clockwise in nature, so it will come positive, so that will come plus 12.5 kilonewton meter. Right. Then we'll proceed to your next span, that is MFBC. Okay. In BC, a UDL is acting throughout the span of 6 meter of 15 kilonewton per meter. So your MFBC, that is fixed moment for BC, comes equal to minus WL square divided by 12 over there. So W is here 15, L is here 6. So W 15 into 6 square divided by 12, that comes equal to minus 45 kilonewton meter. Okay, you solve this, you will get this as minus 45 kilonewton meter. Same way, MFCB, restoring moment will be clockwise in nature, so it will come positive. WL square by 12, it will come plus 45 kilonewton meter. Then the last span, that is MFCD. In CD span, again a UDL is acting over there, but now distance is here, length of CD span is 4 meter. So this comes again equal to minus WL square divided by 12. W will remain same, UDL 15, and length will get changed, that is 4. So this comes equal to minus 20 kilonewton meter, and MFDC will get as plus WL square divided by 12, so that will get as plus 20 kilonewton meter. So this will be my total fixed end moments which I will get over there. Right. Then after this, we'll proceed to a step number 3, that is the calculation of distribution factors. distribution factor, that is DF you have to calculate. Okay, so for DF calculation we have seen the table over there. In table your first column that comes equal to joints, after that members meeting this joint, then relative stiffness K, total stiffness summation of K, and last is DF is equal to K upon summation of K. So this constitutes of your whole table for calculation of DF. Right. So while considering joints, which joints you have to consider here? I have told you in your previous lectures, that is for calculation of distribution factor, you are considering joints which has more than 2 or 2 members, 2 or more than 2 members. Those particular joints you have to consider over here. So such joints are which one? Such joint are B and C. If you consider for joint A and for joint D, those are your single jointed member. For those, distribution factor will always remain equal to 1. But your first joint will consider, so first joint is your B, members meeting joint B are BA and BC. So I am writing here BA and second is your BC. Always you have to write the near end first and far end the second one. So your far end for the first member is A and far end for the second member is C over there. Okay. Now if you see the capability of the support, joint A is the fixed support over here. So fixed support is called as your a capable support. Right. This one, that is the intermediate roller, and C is also the intermediate roller. So those are also considered as capable supports again. Same way at joint D, it is also fixed one, so that will be also considered as capable joint. So if you see in your total numerical, whatever supports are given to you, those are your all capable supports over there. Okay. So in relative stiffness values, all values will be directly equal to I by L. But we'll see. Okay, so first your member is B to A, moment is getting transferred, so A will be your farther end. We'll check A end is capable over here. Okay, so for capable end, relative stiffness comes equal to I divided by L of member BA, that is your 4. So I by 4, this comes equal to 0.25 of I, right? Then next for BC member, far end is your C, but C is also your capable support over here. So for capable support, this relative stiffness again comes equal to I by L. L of BC is given to 6. So I by 6, it comes equal to 0.167 of I. Okay. So total stiffness for this will be equal to 0.25 I plus 0.167 of I comes equal to 0.417 of I. You check this. So total stiffness will get equal to 0.417 of I over there. Okay. Then for calculation of DF is equal to K divided by summation of K, that is 0.20 for BA, 0.25 divided by 0.417. You get these values almost equal to 0.6. And same way for BC, K divided by summation of K, you get this value almost equal to 0.4. Summation of these total two shall come always equal to 1. Okay. Then same way we'll consider now second joint, that is joint C. Members meeting joint C are CB and CD. I'll write over here CB and CD. So in first member your B is the farther end, and in second member your D is the farther end. We'll check. So for CB, B is your capable support over here. So for capable support, your this relative stiffness value comes equal to I by length of CB, that is 6 again. So this comes equal to 0.167 of I. Same way for CD, D is the farther end, that is again a capable support. So for that, relative stiffness comes equal to I by L. L of CD is again 4. So I by 4, it comes equal to 0.25 of I. So this comes equal to again 0.417 of I. Okay. Then DF for CB member, it is equal to K divided by summation of K, that is 0.167 divided by 0.417. This comes equal to 0.4. And for CD, DF equal to K 0.25 divided by summation of K 0.417. This comes equal to again 0.6. So total again you must get this equal to 1. That is DF for a particular joint, the number of members meeting, summation of all the DFs shall come equal to 1 always. Okay. So this will be our calculation for distribution factors over there. Then after that we'll proceed to your next step, that is moment distribution table. Moment distribution table. In this I have told you your first 4 rows, those remains common in this always. That is the first row, it is the joints that you have considered. Okay, second is the members meeting these joints. Third row, that is the distribution factors you have calculated, and this fourth row is the fixed moments over there. So first we will see joints over there. Which joints you have to consider? You have to consider all the joints given in the beam over there. So your first joint is A, second joint is B, third joint is C, and the last joint is here is D over there. Okay. Okay. So I'll start with my first member. In second row, you have to consider the members over there. So I'll start with my first member, that is for joint A, you are having single jointed member over there. So that comes equal to AB. Next, for BA, members you are having BA and BC. Next way, for C joint you are having members CB and CD, and for last member you are having member is DC over there. Okay. Now distribution factors that you have calculated over here. For BA you have got that as 0.6, for BC 0.4. Next, for CB 0.4, and for CD you are getting 0.6 again. Okay. For single jointed member, these distribution factors will remain 1. Next, you have to write is what? That is the fixed moments over there. So fixed moment for AB I am having minus 12.5. Next, for BA I am getting plus 12.5. BC I am having minus 45. CB I am having plus 45. Next, CD you are having minus 20, and for DC I am getting that as plus 20. So what are these fixed moment values I have got in my previous step that I have written over here. Right. Now along with this you are having one extra moment given to you. That is what? A external moment, that is the central moment is acting at this point C, that is concentrated moment. You have to consider this in this table over there. Okay. But that moment is applied at joint C over there. So at joint C, how many moments will be acting? Those will be your fixed moment for CB, fixed moment for CD, and along with those two, one more moment, that is 10 kilonewton meter is acting over here. So that moment I'll be considering over here. That is that 10 kilonewton meter moment I'll be considering here over there. Okay. So total moments acting at joint C are 3. Okay. Now what are 10 you have considered? We'll see about the sign convention for this. What are moments we consider in this fixed moments? We consider restoring signs always. Okay. So whatever moment is given to you, that is clockwise over there. So for restoring moment we consider opposite signs over there. So always consider opposite nature moment, that is minus 10 over here. If this will be given anti-clockwise, so that will become positive 10. If this is given clockwise, that will come negative over there. So these 3 moments will be acting over here. Getting? After this, what you have to do is the balancing the moment. Now for balancing the moment, firstly what you have to check, which support is incapable to, that is which cannot resist the moment. That moment you have to make the 0 over there. But if you see here, all the supports here coming are your capable supports over there. So for capable supports, there is no need of balancing any type of moment. Directly after the fixed moment, whatever you will do, that will be the distribution of moments. That will be the distribution of moments. Now distribution of which moments you have to do? The moments for which you have calculated the distribution factors over there. That is this 0.6 and 0.4, and this 0.4 and 0.6 over there. Okay. So summation of this 12.5 minus 45. So whatever you will get magnitude, that will be negative over here. So that magnitude multiplied by 0.6 and that magnitude multiplied by 0.4 will be distribution for BA and BC respectively. But condition is what? While doing the distribution, whatever signs you are considering, that those are opposite over. That is, this magnitude comes negative, so your distribution will be positive. If this magnitude comes positive, your distribution will be negative over there. So if you see, do the summation of these two values multiplied by 0.6 and 0.4, you will get these values as plus 19.5 and this value will get as plus 13 over there. Okay, same way distribution for C joint you have to also do. Okay, for C 45 minus 10 and minus 30, so 45 minus 30, that is you'll get plus 15 over there. 15 into 0.4 and 15 into 0.6, that is 6 and 9, but you have to do the distribution with opposite sign, so those will come again negative over there, right? So this will be my distribution over there. So after doing the distribution, next part that will be your carry over there. Now carry over of which moment you have to do, for which you have calculated the distribution factors over there, and for which you have carried out the distribution over there. Okay, now BA moment will get carried over to AB over there, but condition is what, your A must be capable. Okay, it is capable, so this carry over is possible. Next BC moment will get carried over to CB, but condition is what, your C, that is farther end, must be capable. Yes, it is again capable over there, so this carry over is possible. Same way CB moment will get carried over to BC, since B is the capable support. Also your this CD moment will get carried over to DC, because your D is also capable over there. Now carry over factor is your 1/2 over there, so half of the moment will get carried over to this, so half of 19.5 you will get as plus 9.75. next half of 6 you will get as minus 3, half of 13 you will get as plus 6.5, next half of 9 you will get as minus 4.5 over there. So this will be your carry over of the moment which you have distributed for the members over there. So you have to repeat these cycles again and again. Just remember, whatever this 10 kilonewton meter extra moment was given to you, that we have considered over here. Okay, if it is not given, then no problem, but you have to consider this moment only once over there. Okay, next again will be carrying out the distribution over there. At least you have to perform minimum 2 to 3 cycles over there, or the answers up to you are getting in 0 point or not. Okay, so distribution for this again, check distribution of which moment you have to do. Here you are having 0, so 0 minus 3, that will be minus 3, minus 3 into 0.6 and minus 3 into 0.4, negative factor you are getting, so distribution will be your positive in nature, so 3 into 0.6 and 3 into 0.4, so that will come 1.8 and 1.2, right? Same way distribution of 6.5, and here you are having 0, so this will be your plus 6.5, distribution will be now negative over there, so 6.5 into 0.4 and 6.5 into 0.6, you will get those values equal to minus 2.6 and minus 3.9. so after that again is the what, that will doing the carry over, same cycle you have to repeat. Okay, so half of 1.8, that will come equal to 0.9, next half of 1.2, that will come equal to 0.6, half of 2.6, that comes equal to minus 1.3, and then half of 3.9, that comes equal to minus 1.95. so you are not getting the answers in 0 point over there, so what we'll do, we'll again do the distribution over there. Okay, the cycles how many you performs, that your perfection increases for getting the correct answers over there. Okay, so distribution of again these two moments you have to do. Okay, I'll square these moments for which you are carrying out distribution over there, so that table you'll understand properly. Okay, so this minus 1.3 you have to distribute, minus it is, so distribution will be again positive in nature, so 1.3 into 0.6, that will get as 0.78, and 1.3 into 0.4, that will get as 0.52. next 0.6 into 0.4, this will be your summation positive, so distribution will come now negative over there, so 0.6 into 0.4, that comes equal to 0.24, and 6 into 6, that is 0.6 into 0.6 will come 0.36. so almost in 0 point I am getting, but I want to get some more answers in perfection, so what I'll do, I'll carry out one more carry over for this. So I'll repeat the same cycle again for carry over. So half of 0.78, that will be your plus 0.39, next half of 0.52, that will be plus 0.26, next half of 24, that will be minus 0.12, and half of 36, that will be your minus 0.18. Now I told you in the previous lecture, when your cycles are getting repeated, where you have to stop the table over there. You have to stop the table always doing after the distribution order. Okay, otherwise what will happen, your the summations will not come correct over there. That is, you have to balance those moments, that balancing will not come correct. So at last, where you have to stop the table after doing the distribution when your cycles are getting repeating. Okay, so 0.12. So again here 0 I am having, here 0 I am having. So these two moments I have to distribute now. Okay, so 0.12. So this is your again negative. So distribution will be again positive. So 0.12 into 0.6 and 0.12 into 0.4, I get this value as 0.072, and this value I get as 0.048 over there. You check this value. Again 0.26 and 0, distributing for 0.4 and 0.6. This is your positive summation. So distribution will be now negative again. I get this value as 0.104, and this I am getting as 0.15 of 6. Okay, now we can stop the table over there because almost answers are in 0.0 and 0.1 over there. So we can stop the table over here. So whatever final moments you'll be getting, those will be over here, final moments. Okay, so final moments we'll write over here. What you have to do now, you have to do the summation of all the moments from this fixed moments over there, because here we have not applied a balance moment. So initial moments are only your fixed moments, initial moments itself are your fixed moments over there. So final answers I'll write over here. So summation of all these moments, if you check, you'll get this as minus 1.46. You check this value, I get that as minus 1.46. Same way, this I am getting as plus 34.65. This I am getting as minus 34.65. Okay, this I am getting as plus 43.42. This I am getting as minus 3.42, and last value I am getting as 13.37 over there. Okay, so these final moments I am getting over here. Okay, I'll write the values for this. See, this is your MAB, this is your MBC, sorry, BA, this is your MBC, this is your MCB, this is your MCD, and this is your last MDC over there. So this final moments values I am getting. Now what we'll do, we'll check your conditions of equilibrium over there. We are solving a slope deflection method over there. So condition of equilibrium first will come at point B, at joint B. Okay, what will be that? MBA plus BC shall come equal to 0. Check whether you are getting plus 34.65 minus 34.65. Okay, I am getting 0. Second condition will be what? At joint C, that is MCB plus MCD plus this 10 shall come equal to 0, or difference between these MCB and MCD shall come equal to 10 over there. We'll check over there. See, this you are getting plus 43 and this you are getting minus 33 over there. So if you see the difference, that you are getting as plus 10 over there. So whatever values I am getting, those are coming my correct values over there. Okay, so if you see whatever this influence of this 10 kilonewton meter moment is coming, that is coming over here, difference between these two values, that is exactly equal to 10 over there. Okay, now what we'll do, we'll plot the bending moment diagram for this. Bending moment diagram by superposition. Okay, A, this is my B, C, and here I am having D over there. Okay, so first moment, our sign conventions are normal one, that is negative, positive, and negative over there. Okay, so first member, that is AB. So moment you are having here is AB. So MAB I am getting as minus 1.46. Negative it is, so plot it on upward side, 1.46. Right. Next, BA moment I am having as 34.65. So again positive, so it will be plotted on upward side, 34.65. Next, BC now member. In BC member I am getting BC as minus 34 and CB as plus 34. So both will be plotted on upward side again. So minus 34 is already plotted. Just what I have to do is I have to plot this CB moment over there. CB I am getting plus 43 over there. So somewhere here it will be 43.42 over there, right? Then in next member in CD and DC, CD I am getting as minus 33 and this I am getting as plus 13. So both will be again plotted on upward side as per your sign conventions. So minus 33, it will be somewhere over here. This is your 34, so 33 will be lower than that. So here I am writing as 33.42 and the last moment I am getting as 13.37. Okay, this I have shown actually so bigger one, so I'll manage that up to here over there. Okay, so this I will join with these support moments with your straight lines over there, right? So now after this what you do, these are your support moments over there. Now span moment will be superimposing on this. So span moment in your first member, that is AB, that will be your WL by 4. Okay, so that I am getting as WL by 4 equal to 25 into 4 by 4. So 25 I'll get that. Okay, so 25, that will be somewhere here and it will follow a triangular path over there. Okay, same way in your second span, that is BC, UDL is provided to. So maximum span moment for UDL is WL square by 8. So 15 into 6 square divided by 8, I get that as 67.5 over there. Okay, so 67, here I am not having the space, so you manage the values of that. So that comes here equal to 67.5. This I am getting as 25 over there. Okay, WL by 4, this is your WL square by 8. And in last member, that is CD, again I am having UDL throughout the span. So maximum span moment will be again WL square by 8, that is 15 into 4 square divided by 8. I get that value as 30 over there. So 30, somewhere here it will be. So this value I am getting as 30. This will be your WL square by 8. Same way this is also your WL square divided by 8. And this value is your WL divided by 4 over there. Just what you have to do is, you have to shade this superimposed part over there. Okay, so this will be your BMD by superposition. So that ends over there. See, again in bending moment diagram also you can see the difference of this strain over there. Concentrated moment of strain acting over here, that is seen over here. See, this is your 43.42 and this is your 33.42. So whatever this difference you are getting over here, that difference is your moment of this concentrated moment, that is strain over there. Okay, I hope you have got this numerical very easily. It is simple one. Only just thing is you have to keep very detailed, or you have to keep very keen eye while solving this moment distribution table over there, and also while calculating distribution factors over there. Because if this step goes wrong over here, your this distribution factors will go wrong and your this complete table will go wrong over there. So solve this very carefully over there. Okay, if you are having any doubt, you can comment again. Thank you so much.